Happy New Year, everybody. Good to see you guys again. Today, what I'm going to do is I'm going to go over the trig test that you guys wrote before the break as a way to review trigonometry for your final exam, and also so that you guys can see where you made your mistakes, because that's usually the best way to learn, actually, is from understanding where you went wrong. Okay, so I will also post this full solution on D2L so that you guys can actually go over all of the questions as well. But you may want to take some notes as you're writing so that you can, particularly if you remember the question that you were guessing on that particular question, then you're going to want to have some paper, pencil, calculator, so that you can take some notes as you go through this. Okay, so the first question, question 1. What is the measure of angle x if sine x equals 4/9? Okay, so if you can imagine here a triangle, and you don't necessarily have to do this to answer this question, but if we have a right triangle, right, let's say that this is our x over here. Okay, now SOHCAHTOA, right? These are our three trig ratios. So the sine ratio for angle x is the opposite side to the hypotenuse. So if you remember from before the break, the hypotenuse is always across from the right angle. So that's this guy over here. On the opposite side is the one across from the angle. So that's over here. So essentially what this triangle would look like is that the sine of x is opposite, so the 4 is the opposite over the hypotenuse. The hypotenuse is 9. So this side you could say is 4 and this side is 9. And what we're basically looking for is what is angle x. Okay, and again, you don't have to draw this triangle to be able to answer this question, but it's nice to be able to visualize it. Okay, so sine x equals 4/9. Now, if you know the ratio and you're trying to access the angle information, to find that information in your calculator, where is it stored, you have to use the sine inverse button. So x is going to be sine inverse of 4 divided by 9. And if we take out our calculator, I'm going to do that right now, right? The inverse button is the sine, just above the sine button, you have to use the shift button. So if you can see at the top first, you can see that my calculator is in the degree mode. At the very, very top, you can see the DEG, so that's really important. So I'm going to hit shift and then sine inverse, and then I'm going to go 4 divided by 9, close the bracket, equals, and you can see it's 26.38. So if I go back to my options, 26 degrees is gonna be the one that works. Okay, so that's 26 degrees. Okay, so that's the first one. Question 2. Given the triangle below, which of the following is the correct ratio for tan Q? Okay, well, Q is over here. That's this angle over here. And again, I know that this was an online test, but really important that you have out a piece of paper and a pencil so that you can redraw the triangle and actually label these sides on paper. Okay, so SOHCAHTOA. Okay, tan is opposite over adjacent. So if I'm labeling all my sides, my hypotenuse is the one that's across from my right angle. So that's this guy over here. The one that's opposite the angle in question, in this case it's Q, is the one that's across from the angle. So that's this guy here. So that's my opposite. And the adjacent is the one that's left, right? So that's the adjacent. So if I'm looking at tan Q equals opposite over adjacent, the opposite is 8, the adjacent is 15. So that's 8/15. And that's that one. All right. Next, the angle formed between the horizontal and the line of sight looking upwards is called the angle of. Now, if you didn't get this, then you are not taking advantage of the fact that I allowed this to be open book. And I had the completed notes online. So you should have gotten this one. And actually, 71% of you did, so that's good. But there's 72% of you, 28% of you got this wrong, which means you didn't look it up if you didn't know. So you got to do that, right? If I'm letting you have open book assessments, then you got to look it up. This is called the angle of elevation, right? If you're looking upwards, it's called the angle of elevation. So that is this one. Okay. All right. Now, in which of the following triangles is sine of A equal to 0.8? Okay. Well, basically what you have to do here is kind of do trial and error and look at all of the different triangles one at a time. So actually, I'm not going to start with the first one. I want to show you how it would work if you picked one of the other ones first. So let's say I started with this guy. Okay, well, firstly, sine is opposite over hypotenuse. So here is my A. And if I label my opposite, that's across, so that's 5. And my hypotenuse is across from the right angle, so that's 8. So sine of A would be 5 over 8 because it's opposite over hypotenuse. If you put that into your calculator, 5 over 8 is actually 0.625. Okay, and you could do that by just going like this. 5 divided by 8. Oh, whoops, I have to clear that. Sorry. 5 divided by 8 equals 0.625. Okay, so that's not going to work. So it's not this one. Okay, if I look at this one, let's say, here's A. Okay, if I label my opposite side, that's across from here. That's my opposite. I don't know what that is. And this is my hypotenuse. So my sine of A is something I don't know over hypotenuse. So it can't be 0.8 because I don't know what the opposite is. In fact, the 4, the one that I do know is the adjacent side. So it's not this one. Okay, I'm going to go to this one next. Here's A. Right here. And if I label my sides, well, C is my right angle, so across from it, that's my hypotenuse. A is over here, so across from it, that's my opposite. So if I go opposite over hypotenuse, that's 4 divided by 5. And if I put that into my calculator, 4 divided by 5, I get 0.8. Okay, so that's 0.8. So this is the one that I'm looking for. It's this guy. Okay. All right. Question 5. For a particular angle in a right triangle, the ratio of the side adjacent to the angle over the side hypotenuse to the angle. Okay, so ratio of adjacent to hypotenuse, A over H, is 3 over 5. The measure of the angle rounded to the nearest degree is. So what is the angle? If A over H is 3 over 5, what's the angle? Well, so ka toa. What's A over H? A over H is cosine. So the cosine of the angle is that. What's the angle? Well, just like the very first question that we did, we have to use the inverse function, right? So we're going to go theta equals cos inverse of 3 over 5. And when we do that on our calculator, we have to use the shift button again to get the cosinverse. 3 divided by 5 equals, we get 53 degrees. Okay, so that's this one. Okay. Question 6. A right triangle has an acute angle of 72 degrees. The other acute angle is what? Well, this is where if you don't know what to do, it's actually helpful to create a drawing. So that's what I'm going to do. A right triangle. So I'm going to draw a right triangle. Okay. Well, a right triangle has a 90-degree angle. Okay, so a right triangle has an acute angle of 72 degrees. That's this over here is, or one of them anyway, 72 degrees. What's the other acute angle? Acute means it's less than 90. Well, this is where we have to use the fact that all three angles add to 180. So the leftover angle is going to be what's ever left over from 180 if we take out, subtract out the other two. And if you go 180 minus 90 minus 72, you're going to get 18 degrees. So that's what should go here. Okay. All right. Question 7. Whoops, I got to go here. Okay. Determine the measure of angle X rounded to the nearest degree. So this is one of these questions where we have to use trigonometry to find either a side or an angle. And the very first thing you want to do whenever you're finding either a side or an angle is label the triangle, right? And what I mean by label is like whatever angle you're using, label opposite, adjacent, hypotenuse. Right? If we're trying to find angle X, this is the angle that we're going to use to label our sides. So I'll start with the hypotenuse, right? The hypotenuse is across from the right angle, which is here. So this is the hypotenuse. Okay. The opposite side is the one that's across from the angle I'm using. So that's, if I go across from the angle, this is my opposite side. And the adjacent is the one that's left over. Okay. Second thing that I need to do is pick a trig ratio. Right? Well, let's write out our SOHCAHTOA. Okay. Now remember, when you're picking a trig ratio, you're only allowed to have one unknown. And all of these trig ratios have 3 unknowns. So I've got to know 2 out of 3. The unknown that I don't know here is the angle, which means I've got to know 2 sides. The 2 sides that I know are the opposite side and the hypotenuse. So I've got to use the trig ratio that uses opposite and hypotenuse, and that's the sine ratio. Right? So I'm going to pick a trig ratio and fill in what I know. Right? So if I have sine theta equals opposite over hypotenuse, well, what do I know? I don't know the theta. I'm going to call that x because that's what it's called in the diagram. But I do know the opposite. The opposite is 12.6. And I do know the hypotenuse. It's 18.9. Okay. Now in step 3, I solve for the unknown. I think in your notes I may have broken step 2 into 2 parts, right? Pick a trig ratio and then fill in what you know, but same sort of idea. Okay, so solve for the unknown. Well, here we're trying to find an angle and we know the ratio. We've got to use sine inverse. So x is going to be sine inverse of the ratio, 12.6 divided by 18.9. So I'm going to use my calculator to do that. Sine inverse of 12.6 divided by 18.9, and I get 41.8. 41.8. So I can't remember if the angles were given to the nearest whole number or decimal, but I'll just remember 41.8 right now. 41.8, so that would round to 42, right? So 41.8 rounds up to 42 degrees, okay? All right, now question 8 is similar, but now we're finding a side instead of an angle. Well, we're gonna start exactly the same way. We're gonna label, okay? Now, here we know an angle, so that's gonna be one of our knowns, okay? Because we're trying to find a side, that's one of our unknowns. So we've gotta use the angle that we know to label our triangle. So this is the angle that we're going to use, the 32 degrees, okay? Now here's my right angle, so across from it is the hypotenuse. Across from my angle is my opposite, and then the other one's the adjacent. Okay, so here's my TOA, and I need that because the second thing I need to do is pick a trig ratio. And here, I know the angle, I want my opposite, and I've got my adjacent. So I've got to pick a trig ratio that includes opposite. So that's either going to be sine or, whoops, this should be TOA. Sorry, what am I doing here? It's either going to be sine or tan, right? Cosine is not going to help me here because I'm looking for the opposite, and cosine doesn't involve opposite. Okay, but the other side that I know is the adjacent side. If I pick sine, I have too many unknowns, so I've got to use tan. Okay, so that's what I'm going to use. Tan theta equals opposite over adjacent. And I'm going to fill in what I know. So tan of 32 degrees equals opposite, I don't know, that's x over 2.9. Okay, now this tan 32 degrees, here we have the angle and we want the ratio. This information is stored in the memory of our calculator. So now we just go back to the calculator and enter in what's the tan of 32 degrees? Tan 32. And that's 0.625. The 4 would round up to a 5 because the next digit is 8. So I'm going to enter that in. Instead of tan 32, I'm going to write 0.625, and that is equal to x over 2.9. Okay, now if you wanted to make this into a fraction, you could put that over 1. Okay, now this looks very similar to all of the other proportional reasoning equations that we were solving, right? How do I solve for x here? Well, what's being done to it? I'm dividing it by 2.9. So to undo that, I need to multiply both sides by 2.9. Okay, now these undo each other, which means that x is going to equal 2.9 times 0.625 divided by 1. And I just need to do that on my calculator. 2.9 times 0.625 divided by 1, and I get 1.8125. So 1.8125, and if you look at what's going to match that in the options, it's the 1.8 meters. Okay, so that was, I don't know what number, we're on number 8. And now we're going to go on to number 9. So here's another one, determine the length of side x. So same sort of idea here. We're going to start by labeling. So here's our angle. Okay, here's our right angle. So across from it, this is our hypotenuse, right? Across from the angle is the opposite. And then this is the adjacent. Okay, so here's our TOA. Okay, and if you look at which one is going to work here, well, we want the hypotenuse. So we've got to use a trig ratio that includes hypotenuse. So either sine or cosine. Tan is not going to work. And the one that we've got is that adjacent. So I've got to use the trig ratio that includes adjacent and hypotenuse. So that's going to be cosine. Okay, so I did labeling, I picked my trig ratio, and now I'm going to write out that trig ratio and fill in what I know. So the cosine of 42 degrees equals adjacent 8.5 over x. Okay, and again, I'm going to access what is the cosine of 42 degrees by using my calculator. So cosine of 42 equals 0.743. Okay, so 0.743 equals 8.5 over x. And once again, if I wanted to, I could put this over 1, because anything divided by 1 is itself. Okay. Now I have one of these situations where x is in the denominator. Okay. And so there's a number of directions that I could go here, but one of them, and the way that we dealt with this with proportional reasoning, is that I could just set this up as a new equation where I set the reciprocals equal to each other. And the reciprocal means that I flip the fraction. So instead of writing 0.743 over 1, I write 1 over 0.743. But then instead of writing 8.5 over x, I write x over 8.5. Okay, and that's a really simple way to do it. And now how do I solve? Well, what's being done to x? I'm dividing it by 8.5. So what do I need to do to undo that? I need to multiply both sides by 8.5. Okay, and then these are gone on the right. So I get that x equals 1 divided by 0.743 times 8.5. Whoops. And if I put that into my calculator, 1 divided by 0.743 times 8.5 equals, whoops. Oh, it looks like this calculator, okay, 0.743 equals, and then I'm going to go, so that's, on this calculator, it doesn't do, then I'm going to go times, so it's going to take the answer times 8.5. It shows you got to get to know your calculator well. Okay, this is the first time I'm using this app, actually. So this is what, 11.44? 11.44. There we go. So that's this one, 11.4 meters. There you go. Get to know your calculator. I should practice what I preach. Okay, so next, solve the following triangle and round all side lengths to the nearest tenth and all angles to the nearest degree. Okay, well, solving a triangle means state all sides and all angles. Okay, and so that's why you had all of these little boxes where you had to have 6 pieces of information, 3 angles, 3 sides. Now, whenever you're asked to solve a triangle, you have to be given 3 pieces of information, either 2 angles and a side or 1 angle and 2 sides. And in this case, you're given 1 angle, which is angle C, right? You have a box that tells you angle C is 90 and 2 sides. So we know AC is 14 and AB is 21. Okay? So the other thing that you need to remember about solving triangles is that you've got 3 tools. Whoops, tools. And they're not in no particular order. One of them is the Pythagorean theorem. Right? This is a squared plus b squared equals the hypotenuse squared. And we can use this to get the third side of a right triangle, if we know the other 2. The second thing is we've got trig, and we can use this to get an angle or a side. Okay. And the third thing is angle sum of a triangle is 180 degrees. And we can use this to get the third angle in a triangle. Okay, if you know the other two. So if you think about where can we start here? Well, we could start by using the Pythagorean theorem to get this side. That's one option. Or we could use trig to get one of the two unknown angles. And it really doesn't matter where you start. Okay, so let's say we decide to start with Pythagoras and start to get side CB. So what I'm going to do is I'm just going to relabel these and say, okay, well, firstly, this long side, the 21, it's across from the right angle. So this is my hypotenuse. And when you're using the Pythagorean theorem, and this is our little review of Pythagoras, by the way, this is the longest side. So this has to be labeled as H, and then the other two are A and B. Okay, so if I'm filling in for the Pythagorean theorem, right? And the first thing I'm going to do, and I don't have to start with this, is find side CB. Okay, so how do I do that? I'm going to use Pythagoras. So a squared plus b squared equals h squared. And then I'm going to fill in what I know. So what do I know? I know that a is 14, so 14 squared plus b I don't know, so I'm just going to write b squared equals h is 21, 21 squared. Okay, well, where can I go from here? Well, I can write out, well, what's 14 squared? It's 14 times 14, so I'm going to go back to my calculator. And you may have a squared button on your calculator, or if you don't, you can just write 14 times 14. So 14, I have a squared button, it's right here. Squared is 196, and 21, 14 squared equals 196. And 21 squared equals 441. Okay, so 196 and 441. Okay, so 14 squared is 196 plus b squared equals 441. Okay, well, I need to eventually get b, but to get that, I need to isolate b squared first. So how do I do that? I have to undo having 196 on the left side. How do I do that? I subtract it. And I have to subtract it from both sides so that I keep the equal sign happy, right? I got to keep the equation balanced. So this is going to become nothing. And all that I have left now on the left side is b squared. 441 minus 196 is 245. So b squared is 245. Now to undo squaring something, the opposite of squaring something is to take the square root. So b is going to be the square root of 245, and that is, let's see, my square root button is right here. And that is 15.6. And in this question, you were asked to round sides to the nearest tenth. So 15.6. Okay, so that's this one. And that was side CB, so I'm going to, or BC, CB, it doesn't matter. So this is 15.6. Okay, so that's one. Now two, maybe I'll find angle A next. Okay. Okay, now I can't use angle sum of a triangle because I only know one angle. I've got to know two to use angle sum of a triangle. So I'm going to have to use trigonometry, right? So if I'm going to use angle A, now I know that this is 15.6. Okay, I've got to label my sides using angle A. So firstly, my hypotenuse, I've already labeled it. That's right there. Now my opposite side is the one across. So this is my opposite and this is my adjacent. Okay. Now I know all three sides, so I can use any trig ratio I want, but I'm actually going to use the one that uses adjacent and hypotenuse. And that's because those are the two sides that were given to me. So let's say I made a mistake when I figured out the 15.6. If I made a mistake with the 15.6, then my angle A will still be correct because I'm using the two sides that were given to me in the problem. Okay, so that's kind of a trick that you can use to minimize errors, is always try and use the sides that are given to you in the problem or the values given to you in the problem. Okay, so I'm going to use adjacent and hypotenuse, and that's cosine, right? If you have all three sides, well, now you can use any of the trig ratios. It doesn't matter, right? And if we haven't made a mistake with sides BC, then it won't matter, right? And we haven't, so we'll still get the same angle. But I'm still just gonna, I always get in the habit of using the sides that are given to me. So that is the cosine ratio. So cosine theta equals adjacent over hypotenuse. Fill in what I know. Cosine of A equals, because I don't know what angle A is, 14 over 21. And then again, to get the angle, I need to use cos inverse. And when I do that on my calculator, whoops, cos inverse of 14 divided by 21, I get 48 degrees. And here we were asked to round to the nearest degree. So this is 48 degrees. Okay, so A is 48 degrees. Now for angle B, maybe I'll do that down here. You could do trigonometry again, but now we can also use angle sum of a triangle because we've got the other two. So angle B equals 180 minus 90 minus 48, and that works out to be 42 degrees. Okay, so that is solving a triangle. And what you find is, firstly, you can usually start anywhere, but as you figure out more and more stuff, you have more options available in terms of these three tools. Okay. All right, we're almost there. 2 questions left. Question 11. From the top of a tree, the angle of depression of a zip line to a boat on a river is 34 degrees. Determine the height of the tree if the boat is 47 meters away from the base of the tree. Okay, well, let's draw this first. So from the top of a tree, so here's a tree. You could see how bad I am at drawing. Here's the tree trunk. Here's the tree. Okay. The angle of depression to a boat on a river. So maybe here's the tree on the ground, and then here's the river, and here's a boat. Okay, is 34 degrees. So here's the zip line. The zip line is maybe going down to the boat. Okay, now the angle of depression is always between the zip line's line of sight to the boat, so that's this line, and the horizontal. So the horizontal is right here. So this is 34 degrees. Okay, determine the height of the tree. So we want to know what's this. If the boat is 47 meters away from the base is here, of the tree. So what is the height, if this is 47 meters? Okay, and here is our right angle right there. Okay, now it looks right now like we don't have an angle in the triangle, but we discussed this when we talked about angle of elevation and depression. The zip line's angle of depression from the top of the tree to the bottom of the boat is the same as the boat's angle of elevation up to the top of the tree. So this is also 34 degrees. Okay, well now we're just finding the side length x in this right triangle. So how do we do that? We start by labeling sides, right? If we're using this angle, right? Well, here's my right angle. So this is my hypotenuse. X is across from 34 degrees, so this would be my opposite side. And this is my adjacent. So if I'm looking at SOHCAHTOA, and I'm picking a trig ratio, well, let's see. I want my opposite, so I've got to use either sine or tan. Can't use cosine. And the other one that I have is my adjacent. So I've got to use opposite and adjacent. That's tangent. Okay, so if I write out the tangent ratio, tan theta equals opposite over adjacent, fill in what I know. Tan of 34 degrees equals x, because I don't know the opposite, over 47. Okay, well, remember, tan of 34 degrees is in our calculator. So tan 34, that's 0.67. Okay, so let's see. 0.67 equals x over 47. And I can make this over 1 if I want, right? How do I solve for x? I got to multiply both sides by 47. Because I'm dividing by 47. So x is going to be 47 times 0.67. And that's 31.49. 31.49. So this is actually 31.7. So what happened, the reason why it's a bit off is because I rounded this too early. That's probably why. So if we actually go back, let's see what the tan of 34 is. Tan of 34. Okay, so 0.6745. Let's keep extra decimal places. So 0.6745 times 47. There you go, 31.7. So that's probably what I should have done, is just kept extra decimal places. Okay, so that's why I was a couple decimal places off, but hopefully for multiple choice, you guys can match that up. Okay, so I should actually 4, 5. There we go. And then we don't need to put that in. And then you get x equals 31.7. There you go. That's better. Okay. Whew. All right, one more to go. An airplane is flying at an altitude means height, of 7,000 meters. If the angle of elevation from a nearby airport to the airplane is 24 degrees, what is the actual distance between the airplane and the airport? Okay, again, drawing. So, firstly, the airport is on the ground. So here's the ground. The airplane is in the sky. There we go. Okay, what do we know? Well, the airplane is at an altitude, a height of 7,000 meters. Okay, also, this makes a right angle. How convenient. Okay, the angle of elevation from the airport up to the airplane, looking up between the airport's line of sight and the horizontal, is 24 degrees. Okay, and what do we want to know? What's the actual distance from the airport to the airplane? That's this. Okay, so once you have the picture, then it's just a matter of finding a side length again, right? So just like what we did before. So what do? We label side lengths. Okay, so here's my angle. Firstly, here's my right angle, so here's my hypotenuse. Across from 24 degrees is the opposite, and this is the adjacent. Okay, so SOHCAHTOA, right? Here I want my hypotenuse, so I've got to use sine or cosine. Tangent's not going to work because that doesn't involve the hypotenuse. I've got my opposite. I want my hypotenuse. I've got to use sine. Okay, so I'm going to write out sine theta equals opposite over hypotenuse and fill in what I know. My angle is 24. My opposite is 7,000. My hypotenuse is x. Okay, and once again, got to use my handy calculator to find out the sine of 24 degrees. Sine of 24 is, okay, I'm not going to make this mistake again, 0.4067. 0.4067 equals 7,000 over x. And remember, you can make this over 1. Okay, so we're in this situation again that we saw earlier in the quiz where x is in the denominator. Okay, but we can fix that by setting the reciprocals equal to each other. And once again, the reciprocals are when we flip both fractions. So we're going to write this equation instead. There we go. Okay, and then this is fairly easily solvable because all we're doing to x is dividing it by 7,000. So to undo that, we multiply by 7,000. Okay, so those cancel, and we get x is 1 divided by 0.4067 times 7,000. Okay, and let's see what that is. All right, 1 divided by 0.4067 equals, and then I'm going to go answer times 7,000. And I get 17,111.7. So I guess here I rounded a little bit less because it's that one, obviously. Okay, but hopefully when you see that, right, I must have rounded to something 0.41 or something like that. But hopefully you can use your discretion there. Okay. All right. So hopefully you guys can understand your mistakes with this and go ahead and do some trig review. And I will see